Okay, this video is going to work through questions 16 through 18 in the midterm review. Here we're looking at a random variable x with a cumulative density function, capital F of x, given by this formula here. Okay, so here's our function. Now, the first thing we want to do is find the probability mass function, little f of x. The way that we're going to do that is by noticing that, remember, the cumulative distribution function is a step function, and the steps occur at the values of that the random variable can take. So, for instance, I've got steps at -1, at 0, at 1, and at 10. And so those are going to be the possible values of x. So I'm looking at x. And little f of x will be the probability that the random variable takes each of those values. So now the possible values are -1, 0, 1, and 10. And the probability that x takes each of the values is the size of the step at each point. So here at -1, the step goes from 0 to 0.15. So the size of the step is 0.15, and that's the probability that x takes on the value -1. At 0, the size of the step is 0.45 minus 0.15 is 0.30, so that's the probability that x equals 0. And similarly, at 1, the step is from 0.45 to 0.65, so the difference in those is the size of the step, 0.20. And finally, at x equals 10, we step from 0.65 to 1. The size of that step is 0.35. So there's our probability mass function, and we should just double check that these all sum to 1, and they do. So there we go. Okay, so the next thing we want to do is calculate the mean of x. The mean of x, remember, I calculate mu, the expected value of x. I add up over all of the x in my space, x times the probability that x takes that value, little x. So here that's -1 times 0.15 plus 0 times 0.30 plus 1 times 0.20 plus 10 times 0.35. And this gives me an expected value of mu equals 3.55. And then the next thing we're going to do is calculate the expected value of 2 plus x to the x power. Now remember, when I want to find the expected value of some function u of x, I sum for all of the values in the space of x my function u evaluated at the value little x times the probability that x takes that value, f of x. So in this situation, I've got u of x is 2 plus x to the x power. So I've got 2 plus my first value is -1 to the -1 power times 0.15, the probability that x is -1, plus 2 plus 0 to the 0 power, here I'm plugging in x equals 0, times f of x, plus, for x equals 1, I've got 2 plus 1 to the first power times that probability. And then finally, for x is 10, I've got 2 plus 10 to the 10th power times the probability that x equals 10, 0.35. And if I go through and calculate all this, because I'm taking this 12 and raising it to the 10th power, I'm getting a really large number for the expected value. It comes out to about 2.167. Let's see, 107748 times 10 to the 10th power. So a very large number. So that's the end of our video, and we will move on to the next set of solutions.